Hello and welcome to the EPI 2001 course at George Brown College. Epidemiology is a complicated but wonderful thing to study, and we will take a close look at a few aspects of it. First of all, we'll look at the definition of epidemiology. Read this carefully and think about it. It comes from our textbook. We'll be looking at a few aspects of epidemiology: the distribution, determinants of disease frequency. So we'll be taking a look at all of these, and we'll be looking at them as they apply in human populations. Make sure you pause the video right now and think about what this definition actually means and whether you really understand it. Few key words in the definition. Disease. There is a specific understanding of disease which maybe medical doctors and others look at. We'll be looking at a broader understanding. So in this course, we'll be looking at a broader understanding of disease, which includes the above disorders plus injuries, disabilities, and death, all counted as disease. In the more narrow conceptualization of disease, this would be natural history of disease. You have exposure to a pathogen followed by biological onset, and these all are part of the preclinical phase. Symptoms, once symptoms start to appear, that's when it's a clinical phase. That's when medical doctors and nurses in the healthcare industry can start dealing with the disease. Diagnosis can take place anywhere soon after symptoms appear or much later, and therapy, it shows here very closely after diagnosis, but depending on the healthcare system, can take place much later after diagnosis. And here we have the disease process when you think of it as the broader definition of disease. So an agent can be something like hockey stick. Host can be hockey player. And biological onset could be something like, I don't know, broken nose. And so here we have something that would not be considered typical. Obviously, medical doctors deal with this all the time, but this would not be what would be considered, in a narrow definition of disease, would not be considered appropriate, but we're going to be taking a broader look at agents, hosts, and disease in general. Disease distribution. Who, when, and where are getting diseases. Determinant. A factor that brings about change in a person's health or disease status. So this, when we think about these factors and determinants, that kinds of sounds like cause. Okay, and cause is going to be an issue that we'll be looking at closer to the end of the course. Disease distribution. So we already looked at who, where, and when, and we see, well, these are related to person, place, and time. Again, pause the video at this point to read through this, and we'll be taking a look at a few examples, which will be similar to what you will be doing in assignment 1 in the next few slides. Descriptive comparison of who. Actually, it's not just who, it's who and when, because we're looking at age. When do these rates of fractures go up? They go up when people get more elderly. So in women, we know already that we're looking at a factor like osteoporosis that is more common in women and more common after menopause. Whereas in men, there's not the same kind of drastic increase. Again, we're looking at describing the distribution of disease. We're not looking at the determinants. When I look at osteoporosis, when I look at menopause, I'm looking at determinants. Here we have another descriptive visualization of the distribution of disease in Toronto, specifically diabetes, the prevalence of diabetes in Toronto. And so we can see here, this is high prevalence and low income. That's the WHO. Again, high prevalence and low income. That tells you a little bit. For epidemiologists, they would say, okay, we need to look into these neighborhoods to see what's going on here. Well, we know low income, and we may not be able to control that, but how is a low income related to high prevalence of diabetes, and how can we reduce that? Another descriptive visualization of when do people go into. So here we have a visualization of the distribution of ambulatory care visits, which are due to various respiratory diseases. And what we can see is that, well, if you look at the pattern, it's all looking for patterns. These are all related to, sorry, the line isn't so straight, but it's roughly summer. The lower number of visits, whereas the higher number of visits are winter months. And so knowing that, we can look at predicting as a healthcare system, as public health agencies can help hospitals and predict. And what we can also see is the trend is definitely moving, looks like it's moving down over the 10-year period, roughly, which is a good sign. Or may just mean that we're medicating children and adults more with puffers. Another visualization, when and who. We have timeline, 1960 to 1995, and we have mortality rates per 1,000 live births. And so what we can see is that they've been decreasing over that time, which is great. A few key terms that are very important. I'll separate one from the others is endemic. Endemic indicates a disease that is constantly present. So colds, sniffles, headaches, and so on, that are something that's endemic to Canada or to whatever other, like malaria may be endemic to India or parts of India. And a cluster is when we have new cases, right? Something that is a surprise and maybe a danger. And then an outbreak. So these are higher and higher danger zones. So again, take a minute to read through these. Epidemic is when we have something happening clearly beyond normal expectancy. And that's a series of clusters or outbreaks. Okay, so how do we, there's no clear line saying that when does it become a cluster or an outbreak or a series of outbreaks. and then we move from epidemic to pandemic. And very tricky how to make the call for or against epidemic or pandemic for public health officials and epidemiologists. Here we have a map of levels of pandemic, except it's a little bit inaccurate in the title because these are not pandemics. So we see here the word outbreak. This sounds like a cluster. So we're moving towards epidemic. Sorry. And then up to pandemic. Okay, because we said pandemic is when we have it in at least 2 countries. Measuring disease frequency. Quantification of occurrence of a disease in a population. Okay, sounds kind of easy. You just count how many people have a disease. Well, how do we know the person A has disease X? We need to define. So remember a well-defined set. And the disease and mechanism for deciding who has it. Typically, who decides? Okay, so doctors typically decide who has or does not have a disease. And then we need to find a way, another mechanism, to count. So do GPs report it? Do we need to have people report into some kind of a public health center? There's typically, we ask GPs to do that kind of work. And what we're looking for is prevalence and incidence. And as you'll see, they're not necessarily easy to count. You've seen it, had a bit of a taste in a Math 11-12 course, and you'll get a little more complex taste in this course. And again, we need to define the population of interest. What does that mean here? Okay, population at risk, which is going to be called the candidate population. And so you'll see that in the formulas for incidence and prevalence at least. When we look for moving to determinants of disease now, right? So everything is based in the notion of the scientific worldview and in the assumptions that, or the beliefs that epidemiologists bring to the table. And so what we're assuming is that disease occurrence is not random, i.e., we can find the cause. Systematic investigation can identify causal and preventative factors. So we need to do systematic investigation. We don't wait for anything, we have to do work. Making comparisons is the cornerstone of systematic investigations. And so you've seen that in the Stat 1013 course, and you've seen that in the Stat 201 course, how that's very important. And I would add in here not just making comparisons, or looking correlations. Making comparisons. Well, if you're exposed, then you need to get the disease. Kind of makes sense. If you're not exposed, then you don't get the disease. So if exposed equals yes, outcome equals yes. If exposed equals no, then outcome equals no. And the key is that to look for this link between exposure and outcome, and not all, sorry, I should say just not 100% will get the outcome. And that's what makes the whole science of this complicated. I'll just say usually. What is exposure? You've looked at exposure in the previous 2 courses, so you have some sense of what it is. We've also called it the independent variable. And these are all possibilities for that. Typically, it's a categorical variable. When we look at it, in this course, mostly we'll be looking at yes and no. What is an outcome? We've looked at it as also the dependent variable. And here it could be categorical. Remember, that's a comparison of rates, or measurement, comparison of means. Visualization of determinants of health. So you see here, these are all the possible independent variables, exposures. So these are all the exposures that could lead to health or to illness. And same thing here, we have 12 determinants of health described by Health Canada. Take a minute to read over these. Other terminology: illness, sickness, different than disease, health, and wellness. Okay, so those are terms that you need to think about and understand and work with. Role of epidemiology in all of this is to work at the prevention, the treatment, and the promotion of health. Promotion of health obviously has to do with treatment and with prevention. We want to have a more healthy society, we have to come up with better treatments, and we also have to look at prevention programs of some various sorts. And those are tied in with the goal of epidemiology and public health, because in order to work at prevention and treatment, what do epidemiologists do? They provide scientific information to politicians. They establish priorities if they listen. Politicians must listen. And so we had a previous government that did not listen to scientists and did not want them to speak. And so we now have a government that at least promises, we'll see if that happens, promises to listen to scientists and to scientific information and make decisions based on that. But they often don't if they feel that they can't get elected on it. Epidemiologists establish priorities for research and action, or they influence politicians and governments to try to do that. They identify areas into which government should invest energy and money, and they evaluate the effectiveness of health programs. Now here's a bit of a tangent, because we're looking at a mandala of health, which is pseudoscientific. So far we've been talking about scientific, or based on scientific worldview, but when we talk about notions like spirit, then we start getting into the realm where the medical system kind of goes, I don't know about spirit, right? If we can't measure it, if we can't see it, then is it really there? Mind is sort of there because of mental health, and so we can measure mental health, but it often gets just crunched into the brain. And so there's a huge tension between the medical system, which wants to see everything as biological, and the non-medical world, which most of us live in, where we think of mind, spirit, behavior as being so important. And I'll leave it there, as a food for thought. Welcome to the course. Good luck in the rest of it.